Hello and welcome to International Project Management Day. My name is Raja Iqbal. I'm the CEO and Chief Data Scientist for Data Science Dojo. Today I'm going to talk about building data science products and building data science products in a way that they make sense for your business. A little bit about myself. I founded Data Science Dojo in 2014. The idea of Data Science Dojo was that anyone can start learning data science, and hence the slogan, Data Science for Everyone. When we started Data Science Dojo, at that time, 12-week boot camps, one-year master's programs were quite common. And the idea was that you need to be a rocket scientist or some kind of unicorn to be a data scientist. We started with the idea that anyone can start doing and learning data science. And prior to starting Data Science Dojo, I was working for Microsoft Bing in different research and development roles in different teams, actually. I have worked for Bing data mining. I have worked with online ads. I have worked on models that do for click prediction. I have worked in online experimentation and A/B testing. And I have done some work in computer vision and data mining. And I have a PhD in computer science with a focus in these areas. The idea of this talk emerged from my interaction with people and the realization that data literacy is not very common, even among people who claim to be practitioners. And also, beginners and practitioners alike, sometimes they would fret too much about building the model and while ignoring the fundamentals. And also, what we don't realize while building a machine learning model is that the choice of machine learning algorithm, when I say machine learning algorithm, I'm talking about, say, random forest or neural network or deep learning or the libraries like TensorFlow or R or Python. Choice of machine learning algorithm or the library, it is only a small piece of the puzzle. And it is the best practices that matter. And even a good machine learning algorithm may yield bad results if you do not follow the best practices. So let's get started. Let's get started with a very basic question. Do you want your model to be always very accurate? And when I ask this question, most people, they would answer, yes, we want our model to be very accurate. And let's consider this example. Let's get started with a few fundamental questions and ask these questions right now. Do we know what data was considered when we were building the predictive model? What time period the data was? What was the size of the data? How big was it? And what was the balance in the data? Let me try to explain what that means. So when we are building a predictive model, say for predicting fraud in the future, we are a financial company, we're working for a credit card company or a bank, and we are trying to detect whether a transaction is fraudulent or not. Should we consider the data from just last one day? Should we consider the data from last 1 week or 1 month or something else? And how many of the frauds and non-frauds should we be considering? And the third thing is, what should be the proportion of the frauds versus non-frauds in your data set? The next question that we will ask is the metric question. What metric are you using for evaluating your predictive model? Let's say you built a predictive model to predict a customer churn. And customer churn, for those of you who do not know what customer churn is for any subscription-based business that relies on customers that keep paying month over month. If a customer decides to cancel the subscription, what is going to be the impact? So can we predict that the customer who's currently paying is going to cancel the subscription next month? So what if we have built a predictive model that predicts customer churn with 70% accuracy? Now, the question is, we can build a predictive model. We can build a predictive model that can predict customer churn with 70% accuracy fairly easily. Let's imagine that the data set had the proportion of customers, that 70% of the customers were already churning, 70% of the customers were already leaving. And then your model predicts everyone is going to leave your service. The model is going to be 70% accurate, but completely useless. Let's ask some other questions here. How useful do you think this model is, even though the model has 70% accuracy? But the model is not quite telling you what you want your model to tell you. Let's ask some other questions. The repeatability question. The results that you get in while using your model, how many times were you able to reproduce the results? Very often, what happens is that people would split the data into some training and test sets. So it is very common to split your data into training and test sets. And if they don't get a good model, they would split the data again into training and test set. And just by chance, they might get a model that is giving them a good training accuracy and a good test accuracy. The question is, are your results repeatable or not? How many variations of the data set did you try? Think about this. Let's say you don't have a lot of customer churn on a Tuesday, and you don't have a lot of customer churn on Wednesday, and then you have a lot of customer churn on Thursday. What if you picked only one day of the week and took the representation from only that day, and you did well on it? Do you think this results are repeatable on a different day? So if the model works well on some variation of data and does not work well on other variations of the data, this is a bad sign for your model. The question is, would you trust this model? Say your model does very well on a Tuesday data set and does not do well on a Wednesday data set. Would you trust this model? Would you trust this model on a Friday, for instance? You have no idea if the Friday data set looks anything like the training set that you used. Well, the model might perform well. But if the data on Friday is very different from the data set that the model was trained on, your model will most likely not do well. And the next question is the business question. The business question is, did anything else change in the business? For those of you who remember the Netflix subscription fees, when Netflix subscription fees changed, they created two different subscriptions. They separated the online subscriptions and the mail-in subscriptions. Both of them they started charging them separately. So at that time, there was a mass exodus of customers from Netflix. Many people did not like it, and they started leaving Netflix. And at that time, any model that would tell you, or any customer churn prediction model, will actually be accurate because most customers are leaving anyway. So the question is, what if I built a model and released the model around the time when a lot of customers are leaving anyway? Can I consider that my model is improving, even though my model might look good, but did the model actually improve? The next question is, what is the impact of your model? What impact does the model have? Suppose we built a customer churn prediction model and started calling the customers and try to retain them. So the question is, would the impact of the model would be as good on the business as the model looks like? Let's look at a real situation. So this is an example from a real telecom company that reduced their customer churn by 36%. And here is how their model was built. Let's actually talk about how would you build a model. So typically, you will build a model and you will start building a predictive model to predict which customers are going to leave you. And now suppose that you're the machine learning engineer who created this list of all the customers that are likely to leave your service. And the sales team takes over and they start calling the customers, trying to retain them. And imagine, there will always be some people who would like to leave your service. And maybe for whatever reasons, for some reasons they are, because they're busy, maybe they don't even know they have a subscription from you. For a variety of reasons, they are just delaying. If your sales team calls them and tries to retain them, there will always be people who are not going to stay with you. And imagine the impact this model will have. You're starting to call people who are likely to leave your service. And you are reminding them they need to leave your service. And as a result, instead of helping the model, you started hurting. Instead of helping the business, you started hurting the business by calling the people who would have left, and then when you remind them, they actually left. Now, how did this company build their models? This company actually built their models by first detecting the customers who are likely to leave. And then out of all the customers who are likely to leave, they built a predictive model to predict how many of those, or which one of those who are likely to leave will stay if called. There's a subtle difference, right? So the first model, the first approach was perfectly fine in the sense that it was a very good predictive model that was predicting all the people who would leave. But think about this, that if the model is used in a way that is not helping the business, it is actually, at the end of the day, it is a bad model. So the first model was not considering that when the sales team starts calling people, there are some, you are reminding some people that they need to leave. But the second approach, because it consists of two models, the second approach actually is ensuring that you only call those people who are likely to leave and they will stay when called. And this is if you go back and look at the title of this talk, this is precisely the reason. When you're building a machine learning model without an understanding of the business or impact on the business or an understanding of the domain, it can sometimes have a negative impact on your business. So the key learning is a good model with negative business impact is actually a bad model. Let's continue. So there is a lot of popular tools around. You may have heard of Python and R and SAS and TensorFlow, and there is big data libraries like Mahout and Spark, and there are platforms that are offering these services like AWS and Cloudera and Azure. So with all of these tools, I consider these tools to be both a blessing and a curse. The reason being that these models, these machine learning algorithms actually, and the tools actually, they make building models super easy. And what these libraries do is that they create an illusion of understanding. And when I say illusion of understanding is, I will probably share a personal anecdote. I interview a lot of data science professionals or machine learning engineers. And when you ask machine learning engineers, they would have a lot of machine learning techniques listed on their resume. When you ask them, they would tell you that they understand, say, a technique, fairly popular technique in machine learning called logistic regression. When you ask them, okay, so tell me what is logistic regression, they will tell you they used certain Python or R library. And when you remind them that this is not what you're being asked, you are asking about what logistic regression is, most of the candidates actually fail to explain what the actual algorithm is. So these tools, while these tools are very helpful, they will help you build models with relative ease, but without an understanding of the underlying technique, without an understanding of business, without an understanding of the basic principles of sampling and data handling and data cleaning, these machine learning tools can be a curse. And for those who understand all of these best practices, for them it is a blessing because they make your experimentation quite fast. Okay, so by now we understand that there are some pitfalls. By now we understand that there can be issues. So let's start with this. What is the right approach to build a machine learning model? Let's look at this. So building a machine learning model, or the right approach to building a machine learning model is, well, don't think about machine learning from the beginning. Start with the business question. And really, your business does not care about whether you are building a neural network or a random forest, or you're building a parametric model or non-parametric model. What they expect you to do is solve problems. So you will start with some business question. Ask this question: how can we save more money? How can we make our processes more efficient or faster? How can we save money? How can we make our customers happier? Your business will have some, like most businesses, your business will have some constraint or some objectives. Understand: are you losing revenue? Is there too much fraud? Are you not able to forecast inventory? Ask this question and see how you can solve this problem. So now that you have asked the right business question, say you're asking the question of that you want to predict fraud because there is too much fraud for your business, and then you do not have, you're losing money because of the fraud. So how do you solve this problem? Identify which category of machine learning problems is it? Are you talking about clustering? Are you talking about classification or regression or ranking or some kind of association analysis? Or Maybe you don't need a machine learning model. You just need some sort of data exploration and understanding of data. So you will start with the business question, identify which category of machine learning problems you're dealing with, and then you will go to defining the success metrics. And defining the success metrics is very important. If you go back to the earlier part of the talk, we talked about what if you predicted that every customer is going to churn. Your model will still be very accurate because 70% of customers are churning anyway. So you have to carefully choose the metric. In that example that we cited, maybe accuracy is not the right metric. Maybe you're only interested in predicting who is going to leave with accuracy, not as opposed to the overall accuracy of your model. And this concept, what we call recall, is what we need in this case as the metric. And moreover, there are metrics that are actual business metrics. You can build a model that has a good recall, but when you deploy it, it can have negative business consequences. Just like the example, the telco example that we talked about, that your model was able to predict all the customers that are going to leave you, or they are likely to leave you rather. But when you started calling them, you actually hurt the business. And notice that I've not even started talking about machine learning yet. There is no building of machine learning models. I'm talking about pretty much how to set up the problem so far. And even now, the next thing that I will look at is what is the data that I have available to solve this problem. Say I'm building a fraud detection model. My business question is there is too much fraud. Then I identified the problem maybe as a classification problem. Then I identified that I want to have some metric, maybe recall as the metric. And then I go on, what is the data that I have available in my transactions? Maybe the time of the day, maybe the amount of transaction, maybe the location of the transaction, and so on. This is what we call features. So anything that is used to predict the outcome, we call it the features or the predictors, and different domains, they may call them with different names, but the idea remains the same. What is a good predictor for what you're trying to predict? And moreover, you also need to look at, is there any other data that you could have acquired or you could have obtained that could have improved the predictive performance of your model? And once you have obtained all of the data, only then you will go and choose the machine learning algorithm. And once you have reached there, depending upon what kind of data do you have, how much missing values, whether you have a lot of categorical values or whether you have a lot of numeric values, based on all of that, you will decide whether you want this machine learning model or that machine learning model. And there's dozens of machine learning algorithms that exist there, and you will choose from them. And once that is done, the next thing is the parameter tuning. Most of the practitioners, or I should say most of the beginners rather, they would start building a model and they will take the default parameters. But really, most practitioners, what they do is, their job is to extract the right data, choose the right metrics, and tune the model parameters. Nobody would actually go and implement a machine learning model from scratch. So your job is to actually see if you can repeat the results. You will try different variations of the data. You will try one variation for training and another variation for testing, and you will try to repeat these results. If you can consistently repeat the results over time, that actually will show you that you have a good predictive model. And once you have this, even though you have a good statistical evidence that you have a good predictive model, you will still go for more evaluation on a data set that we call the blind holdout data set. The blind holdout data set is a data set that is set aside, sometimes locked away from the person building the predictive model for evaluation purposes. Think of the blind holdout data as the last security check before your model reaches the customers. So once you have the model, you will go and evaluate on the blind holdout data. And once you have evaluated on the blind holdout data, you're going to go ahead and test it on a small subset of your customers. Think of this as this way. If you are given an option that to try out a drug that has only been tested on animals, Would you go ahead and try it? Most people would answer no. And the idea of online experimentation is very similar to a clinical trial. Once a drug has made it out of the lab environment, you tested it on mice or rats or rabbits or guinea pigs. Now, once your drug or model in this case is out of your lab, what do? You don't go out and start selling that drug in a local drugstore. You're going to expose this to before starting to sell this drug at a large scale. You will select maybe a small fraction of the target population and design a controlled study, a controlled experiment, and then see if the drug is actually effective. And once that is done, you will start to increase the adoption. You will start to, in the case of a model, for instance, you will start to test your new model on more and more customers. And once you have tested it out on enough number of customers, this becomes the mainstream experience. And once that is done, you release the model to production, and you check this model in the production environment. And once that is done, your job is really, the model is done, but your job is not done. You go back and start looking at how to acquire more data and extract more features and see what can you do to improve the model. You are always going to be doing something that increases your revenue, improves your profit margins, reduces cost, improves customer satisfaction, and really adds business value in general. And if you have spent some time in industry, you will see that someone very smart, brilliant, they will come up with and suggest something. Yeah, I mean, looks great, but why should we do this? What's the point doing this? Yeah, I mean, I love it. It's a great idea. What value is it bringing to the business? So the question always starts with what will help the business. So how do you start with this? If you have some, you know machine learning now. You have some idea how to build machine learning models. How do you identify what would be a good model to build, or what should we do in machine learning given our situation? You will ask these questions, right? So we have too many frauds that are happening. If we did this, it will result in this business metric. If we could predict customer churn, what if we could forecast sales? If we could forecast sales, this will happen. So you always will actually keep thinking about this wishful thinking, let me put it this way, right? So something is not happening right now in your business, and you will ask this question, I wish if we were able to do this, that would add business value. The next thing is, so you came up with this business question. You decided that you want to predict, you want to forecast sales. What is the next thing that you will do? The next thing that you will do is you will go and ask this question: what are certain things? What are some pointers? In machine learning language, we call them features or predictors, right? What are some predictors or features that can help me predict sales? You will go and start looking at, yeah, I know that table in that database that has some information around sales, and maybe that other team in my company, they have some information, and maybe this third-party data, if we can just bring it in, join it with our existing data set, that will help us forecast sales better. There is this common myth, right? So sometimes people would think that there is yeah, we'll take this black box and put no matter what data is given to us. I mean, this algorithm is amazing, right? So we'll just give it anything, it will just come up with a model. It doesn't happen this way. It doesn't work that way. So this is a myth. And the other thing is that you have to really make sure that you spend, I call it the 80-20 rule, spend a lot of time on your data. That will save you a lot of trouble later on when you build the model. If you do your due diligence while handling data, acquiring data, cleaning data, engineering your features, it will save you a lot of trouble when you have actually built the model. Your model is going to be far more robust and better if you do your due diligence in the data stage. Let's call it the whole data stage, from collection to all the way to feature engineering and cleaning, so on. There is this idea. Acquire as much data as you can. Sometimes the data may be sitting somewhere nearby, and you may not know that the data even exists. Some customer data, someone came and told you, yeah, I mean, we need to predict this, and I think go to that table, and you are just stuck with that table in a given database. But maybe there is another table in the same database. Maybe your partner team has some data set. Maybe the third party has some data set. Go and get as much data as possible. More data is always better than less data. So as I started my presentation, at the beginning of my presentation, I stated that building the model is only a small piece of the puzzle. And if you look at this diagram, if you look at this flowchart, you will realize that, well, we spent very little time on building the model, and all of our activities were revolving around the business. First and foremost, what is the business impact? The next thing was how to identify which kind of machine learning problem it is. And the third thing, and I would consider that, again, one of the most important things, is defining the success metrics. Because defining the wrong success metric, it can actually lead you to all sorts of confusions. You might be thinking that you are doing well because you chose the wrong metric. The example of accuracy that I stated, right? You might be thinking that you are fairly accurate, and hence your model will have a positive impact on the business. Whereas your model is actually hurting your business. And the other thing is the data. And as they say, data is the new oil. If you do not have good data, it is very difficult for you to build a good predictive model. Your data can have issues. Your data can have quality issues, and it can have variety issues. You don't have the right representation of data. You don't have enough samples there. You can have missing values in your data. Your data may not be in the right format. You may not have the right features, or you may not be aware of that some data exists that might be useful for building your model. And for that, understanding your business and understanding the problem, it is absolutely critical. Then, once you have chosen the predictive model, the repeatability. You cannot simply choose a predictive model based on just one random split and assume that this is going to be a good model in the longer run. And I often say that when you're building a predictive model, you have to be paranoid. You have to be paranoid about something going wrong. And for that purpose, we have this data set that we call further evaluation data set, or the blind holdout data set. And the spirit of this data set is that you do not ever look at this data set. You do not ever try to understand what is in this data set. You treat this blind holdout data set as strictly as your future data set. And what do we know about the future data set? Nothing. So you will keep this data, and you would not be testing on this data very often. You will only test on this data when you are absolutely certain that you have a good model, and use that as the last security check. And even after this, you're still paranoid, and you're not going to expose all of your customers to this data. Imagine Netflix or Amazon, if their click-through rate on the recommendation engines, if it drops, if the click-through rate goes down by a mere 0.1%, it may look like, as a result of the new predictive model, if the recommendation click-through rate goes down by 0.1%, it may look like a very small change in the click-through rate. But the reality is, this kind of drop in the click-through rate, it can have a severe impact, potentially tens of millions of dollars of impact on the bottom line revenue of the business. And then, once you have evaluated this on a small subset, the new model on a small subset of customers, then you start increasing the exposure of this model to more customers and make sure that your success was not accidental. And once that is done, you release the model to production. And once you have released the model to production, you do not just sit there and relax. because you have more data coming in, you have new customers coming in, you have new categories coming in, you have new business realities. Things are changing. And you are going to go back, get more data, get more features, consolidate more data sources, and make sure that your data key stays clean. And you go through this cycle over and over. Thank you.